everyone, welcome back to my YouTube channel. My name is Noel from ADDIS University. Today I'm going to show you how you can solve this problem. As you can see here, a man walks at 4 km per hour in the direction of 20 km per hour, and if the raindrop fell vertically at 7 km per hour in still air. Determine the direction in which the drop appears to fall with respect to the man. Assume the horizontal speed of the raindrop is equal to that of the wind. So, as you can see, this problem asks you to use the concept of relative motions and solve the required solution. As you can see here, we are given the man velocity. The velocity of the man is 5 km per hour. We can change into meter per second by using a unit conversion factor, or simply we can use it. And we are given the velocity of wind, which is 16 km per hour, with the same direction as the velocity of the man. And a raindrop fell vertically at 7 km per hour. The velocity of rain, as you can see, this white line is 7 km per hour, and we are asked to determine the raindrop appeal with respect to the man, which means the relative velocity of raindrop with respect to the man. And we can use the concept of relative velocity and solve this problem simply. The relative velocity equation between the wind and the rain is VR is equals to velocity of rain, which equals to velocity of wind plus velocity of rain with respect to water. Then we can simply substitute the value, which means 20I minus 7J, and the relative velocity between, which means the relative velocity of rain is 20I minus 7J, and the relative velocity of equation between B with respect to W and wind and demand is given by VR is equals to Vm plus PR with respect to M. So we can substitute the value simply, and we can get here this value. After this, we can rearrange this equation and we can get the relative velocity of raindrop with respect to the man is 15I minus 7J. After this, we can use the trig identity and simply finished our equations. So the magnitude of the raindrop, the velocity of R with respect to M is given by this, and we can square this value and we will get 16.55 km per hour, and the direction theta is given by tan inverse of minus 7I over 15J. Theta is equals to 25.07 degrees. So the direction drop appeared to fail with respect to the man is at an angle of 25.01 measured in the clockwise direction with respect to the horizontal. We can simply solve this problem like this. If you have any question, you can put it in a comment section. Next we will do question number 1 from assignment 6. Until that, have a nice time. If you like this video, make sure to subscribe our YouTube channel and share it for friends. Next we will do question number 1. Until that, have a nice time.